Hello my dear students, today we are in lecture number 25 of standard 11. I am B S Pandey, your physics lecturer. My dear students, in last lecture we have studied about the linear momentum and change in momentum, that is the impulse. We have also studied the mathematical equation of Newton's second law, that is F is equals to ma. My dear students, today I am going to facilitate here a video clip that you can understand the basic thing of Newton's second law and at the fundamental stage how you can use that formula. Although you have studied the same thing in standard 9, but this clip will recall you everything about the Newton's second law. So let me start today's lecture, my dear students. It is lecture number 25th. And we are studying Newton's laws of motion, that is NLM. My dear students, what we have studied actually in this particular section of Newton's second law, before that we have studied the momentum. Let me recall you the momentum we have studied, which is linear momentum, which is a vector quantity. It was mass times velocity, and the direction of momentum actually was defined by the direction of velocity itself. Okay. Then we have studied the impulse. You must go to the previous lecture, and that impulse is change in momentum, that is final momentum minus initial momentum. Okay. Then we studied about the Newton's second law, that was force is rate change of momentum dp over dt, or using this particular concept we got mathematical equation. It was F is equals to ma, and this force must be considered on a specific axis. If we are considering force on x-axis, the total forces, then it will be the mass times acceleration, the net acceleration along that axis only. Alright. If we are considering over the y-axis, then it will be the MAY with the proper axis fixation. On the z-axis, it will be MAZ. That we have studied the equation, mathematical equation of Newton's second law. The student, you have studied the conservation of linear momentum in standard 9. We will also study here, but before that, let me give you a very simple clip that will enable the concepts of linear momentum and Newton's second law of momentum, that is the momentum, that is the force is equals to mass times acceleration. So let's see that clip.
The momentum of a body is defined as the product of its mass m and velocity v. Momentum is denoted by p. Since mass m is a scalar and velocity v is a vector, their product, momentum p, is a vector. In the SI system, momentum is measured in kilogram meter per second or Newton second. Force, momentum and time are interrelated. Let us check some scenarios to illustrate this. A boy standing in a first-floor balcony drops a ball of mass m from a certain height h. As the ball goes down, it gains some velocity and hence acquires a certain momentum. A boy standing on the ground below catches the ball by using a force F. The momentum of the ball becomes zero during the process of catching it, as it comes to rest. Another ball of mass 2m is dropped from the same height. This time, the force required to catch the ball is 2F. Between these two scenarios, the mass of the ball doubles, but the final velocity remains the same. Therefore, the momentum of the ball also doubles. Consequently, the force applied to catch the ball also doubles. Here, the momentum of the ball increases due to an increase in its mass. In the same scenario, if a ball of mass m is dropped from the second floor balcony from a height 2h, its velocity increases and therefore its momentum also increases. Consequently, more force is required to catch the ball. Here, the momentum increases due to an increase in velocity. In all these three scenarios, the ball has some momentum when it touches the hands of the boy catching it. However, the momentum becomes zero as the ball comes to rest due to the force applied by the hands for some time. The force required to stop the ball and the length of time the force is applied are related to each other. A wicket keeper, after gathering the ball away from his body, pulls his hands towards himself to avoid injury to his hands. This proves that less force is required when it takes more time for the ball to come to rest. Now, let us look at another example, where the body is at rest initially. That is, it has zero momentum, and by the application of a force for a certain time, it acquires some momentum. A small car is at rest. 4 persons push the car for a certain length of time, at the end of which the car moves with a certain velocity. We say that the car has acquired momentum. A truck is at rest. The same 4 persons push the truck for the same length of time, at the end of which the truck moves with a velocity lesser than that of the car. However, the momentum acquired by the truck is the same as that acquired by the car. In these two activities, the force applied and the length of time for which the force is applied are the same. Therefore, the momentum acquired is also the same even though the mass of the car and the truck is different. Hence, a body of lesser mass moves with greater velocity compared to a body of greater mass, but the product of the mass and its velocity remains the same in both cases. In these examples, there was a change in momentum due to a change in magnitude of the velocity of the body. There was no change in the direction of motion of the body. What happens when the magnitude of the velocity of the body remains the same and only its direction of motion changes? Since the velocity vector changes direction continuously, the momentum vector also changes direction continuously, and this change requires some force. Consider a sling being whirled such that the stone and the thread rotate in a horizontal plane with uniform angular velocity. The magnitude of the linear velocity of the stone remains constant, but its direction changes continuously. To sustain this kind of motion, we have to continuously apply a pulling force on the thread. From these examples, we have understood that a force has to be applied on a body for some length of time, during which a change in momentum is taking place. In other words, the momentum of an object increases when it accelerates and vice versa. Therefore, the rate of change of momentum depends on the acceleration of the object. Newton's second law of motion brings out this relationship between momentum, acceleration, and force. Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts.
I hope, my dear students, that you enjoy that clip, and might be the few things will help you a lot. Here, my dear students, now we are proceeding for the calculative part, that is we are going to study here some numericals, how to solve, where we will use Newton's second law. Okay, that is the equation for the motional objects. Before that, my dear students, I am going to discuss here a simple question which is mentioned in NCERT on the basis of this momentum and impulse. Okay, so here the question. Here a body, this is a wall, the wall, a ball of mass m, it goes and impact over this ball with speed u in this direction. Actually, this makes a direction, suppose it is theta, alright, and reflect back without losing any energy with the same speed at the same angle theta. Okay, if this is the axis y and x, the positive axis, then you have to find the impulse along the two axes, x and y, that is the change in momentum along x-axis and y-axis. You have to find change in momentum along x-axis and change in momentum along y-axis. My dear students, you will get such type of question also to find the force, alright, to find the force if you will have the time to change that impact. Okay, so here you have to find the change in momentum along x-axis and y-axis. Remember, my dear student, if this is the velocity on the straight line, the velocity, it will have the two component, the velocity in this direction, so it will have the two component, one it is in this direction, and along x-axis the another will be in this direction. In same way, if we are having the velocity in this direction, this will also have the same velocity, this will also have the two component. First, let me try to break the component in this direction. It is u sine theta. I hope you understand. And another component, it is u cos theta. Am I right? Yes. Now, another thing. The component of this one, this will have the two component. If it is moving in this direction, then it will have the one component, it will move in this direction, and another component, it will move in this direction. So the component of this two will be the u cos theta in this direction, and the another component, it is u sine theta. Okay, now we are going to calculate here the change in momentum along x and y axis. Here the delta px, delta p, it is along the x-axis, it is p final minus p initial. The mass of ball, it is m, and the same ball, it is reflect back the same mass without losing any energy. Here the final momentum, it is the mass into final velocity, alright, minus mass into initial velocity, it is the v initial. So we can write here the mass is not going to be changed, m, but the final velocity, remember the final velocity is this one, but along the x-axis the final velocity, we are having here the u cos theta, and you can put the direction as well, it is minus I, because the velocity is a vector quantity, minus initial velocity. So the initial velocity is this one, but its component along x-axis, it is the u cos theta along u cos theta and I cap. I hope you understand. Now m, it is u cos theta I and minus u cos theta, I do the twice, so we can write here the minus twice u cos theta, and along which axis? It is I-axis. Or you can write here the 2mu cos theta minus I. Here the momentum changing, but along which axis it is changing? Negative of the x-axis. Now, in same way, my dear students, try to find out the change in momentum along y-axis. You will get the answer 0. Okay. Now you can solve by yourself. We are having the equation for the Newton's second law. We are going to apply here to solve few questions. Okay. The first question. Here, the two bodies are connected with a string and a force F is given. Alright. F, suppose it is 100 Newton. 100 Newton is given. On this smooth surface is smooth, we will study the rough surface also, that is the friction. Here the mass m and this is mass 2m. Alright, you have to find acceleration of the system. First we have to find acceleration of the system, and the second you have to find tension in each string. The two things you have to calculate. Remember, here the value of m, suppose it is given m, it is, let m it is 1 kg, it is given. Okay, how you will solve this type of question, my dear students? So let me solve. These are the few beginning questions. Remember, if this string is inextensible, that is, it cannot elongate. So if this body changes this position 2 meters in 1 second, then of course it will also change its position 2 meters in 1 second. It means both the body will have the same acceleration. Of course, the acceleration A and the acceleration A for this 2m also. Now the free body diagram, my dear students. Here we have break, the tension T, twice mg. Here the normal, suppose N1. Here the mg, normal, suppose it is N2. Alright, one by one we will solve for both the bodies. Let me fix the axis. My dear students, try to remember, I have told you the body will move in the direction we will take the positive axis. We have taken here the positive axis in this direction, the system is moving in this direction. Alright, now for this body, the forces are only one, it is T, and along y-axis it is mg, and on this axis it is N2. So my dear students, the sigma fx can be written as, now it is not 0. Why? Because system is moving with an acceleration a. Alright, velocity is changing. So it will have some force, and it is nothing but the mass of this body, which is m, and acceleration of the system. Suppose it is a, that we have to find. Now here the total forces. How much forces are acting on the x-axis? Only one force, and it is T. So it will be the T equals to ma. The first equation. I hope you understand, my dear students. But along the y-axis, you can see the body is not moving. Along the y-axis, body is in a static state. It is not moving. So we will write the sigma fy, it is 0. And in this case, N2 will be equals to mg. Alright, you can find. This equation will not use anymore here in this topic, but in friction chapter, we will use this concept also. Now, for this body, this was the free body diagram 1 we have done. Now for this body, the free body diagram 2, you can see here the tension, and here the force, which is 100 Newton, twice mg, and the normal reaction. Not, we don't have another forces. Now again here the sigma fx is equals to mass times acceleration. Here the mass of the body, it is twice m. So let me write here the 2m. Alright, acceleration is same and it is a. Both the body moving with the same acceleration, so the acceleration is a. Now the sigma fx, how many forces are acting along the positive direction? Here the axis, you can see, my dear students, it is this one, y and x. This is the positive axis. Here the body is moving in this direction, so this force will be considered the positive. So the F minus, this will be considered negative, T is equals to twice ma, and this is the equation number 2. My dear students, we can put the value of equation 1 in equation 2. We'll have F minus T, which is equals to ma, is equals to twice ma, and F is equals to thrice ma. We have to find the a. It will be F times 3m. F, we are having 100 Newton divided by 3m, it is 1. All right, yes, and it is 100 over 3 meter per second square. Once you will find the acceleration by putting the value of a in any equation 1 or 2, you can find the tension as well. But it will be easy to put the equation in 1 to find the tension. From equation 1, T, you can write here the m, which is 1, times a, you got 100 by 3. This is 100 by 3 Newton. Okay, my dear students, I hope you understand. Now, along the y-axis, you can write again, this body is not moving along y-axis, so you can write the sigma Fy again, it is 0 in this case, and the 1 will be equals to twice mg. Okay, if you are having the value of m and z it is 10, then you can find the value of n1. I hope you understand. One question I am giving you for homework. Now, this is your homework. M, 2m, 3m, and the force is acting here, the 200 Newton. Okay, over the smooth surface. The same question, but first you have to find acceleration of the system. Second, you have to find tension in each string. Tension in each string you have to find, and acceleration of the system. This is your first homework, my dear student. The second homework, m, 3m. Here the two forces are acting. Here it is 100 Newton. Alright, and here what should be the value of F? Alright, what should be the value of F if m is 1 kg, so that the system moves with an acceleration a, it is 5 meter per second square. What should be the value of F? What should be the value of F so that the system moves with 5 meter per second square in this direction? Okay, here I have been given the direction of acceleration. What should be the value of F so that system moves with an acceleration 5 meter per second square? Okay, this is your question. Now, let me solve here the one more question, and then I will give you some more homework. M, 2m, m. Here I am applying the force. Suppose it is 500 Newton. Alright, the value of m, it is 1 kg. 1 kg. What will be the, let me write here, the 100 Newton. What will be acceleration of the system and in which direction? You have to find. Okay, what will be the acceleration of the system and in which direction? And second, find, this is the first question, and second, tension in each string. Tension in each string. Okay, So let me solve this question. First we will do the free body diagram. Okay, here the free body diagram we used to represent weight, here the twice mg, here the mg gain, and the tension. So here tension in both the string, suppose T1, tension in both the strings, suppose T2, and nothing more we are having about this system. One by one we will do the free body diagram. So this is the 1, 2 and 3. Free body diagram 1, we are going to solve this question. Free body diagram 1, sigma Fy is equals to 0. Let us suppose this axis as positive and this one here as positive. We have done with the axis fixation. Okay, my dear students. Now, for one by one, for the third one, always try to solve the question from the bottom one of this type of question. You will get the answer quickly. For third free body diagram, what you can write here, the two forces are acting, one above, it is T1, and the second is below, it is mg. But despite of that, the body is suppose moving with an acceleration a. Remember, my dear students, one thing that will comes in your mind, sir, if this system we are pulling up with 100 Newton, if it is not sufficient to pull the body with 100 Newton in upward direction, what will happen? It will move down, but you have been taking the direction of acceleration in upward direction. What will happen, sir? So my dear students, if you are taking the particular axis, it is y axis as positive, and you have been taking the acceleration a in this direction, then if the body is not able to move up, automatically you will get the acceleration in negative value. It means the body will not move in upward direction, it will move in downward direction. Okay, so don't worry, take the values and try to solve carefully. Okay, the values that will come with a negative or positive automatically will give you the idea whether it is moving in upward direction or downward direction. Okay, my dear students. Yes, here for the free body diagram 3, we can write in upward direction it is T1. What we will write? Sorry, here not the 0. I am very sorry, my dear students. It is moving with an acceleration, so it will be the MA. Alright, it will be the MA. So T1 minus downward force, it is mg, is equals to mass times acceleration. The mass of this body, it is m, and acceleration we suppose a. Remember, all the body will move with the same acceleration. Now this is the equation 1. Put this equation as 1. For this one, what happened? The total force in upward direction, it is the T2 minus the downward force, it is the twice mg minus T1, and it is equals to twice ma. The second equation. Okay, the second equation, but you can simplify this equations 2 as well by putting the value of T1. Here the value of T1, it will be the ma plus mg. So the T2 is equals to 2ma plus 2mg, this one, plus T1, which is equals to ma plus mg. Okay, here the T2 you got how much? It is thrice ma plus thrice mg. Equation number 2. Now apply the equation in free body diagram 1. In this one we are going to apply. Okay, so here 100 Newton in upward direction for free body diagram 1. In upward direction 100 Newton and downward direction the two forces. Why I am writing here the 100 first and then after this forces? Because in positive y-axis we are having the value 100 minus two forces, it is a mg minus T2 is equals to, you can see here the two forces acting downward, is equals to ma, the mass of system, mass of body times a. I will discuss this short trick also to solve such type of question directly to get the acceleration, my dear students. Here you can put the value of T2 also from this equation 2. It is 100 minus mg minus, it is thrice ma minus thrice mg is equals to ma. Alright, yes. So it will be 100 minus, it is 4mg, 4mg. Alright, we have written is equals to thrice 1, 4ma, m times a. So the a can be written as 100 minus 40, it is 60 divided by 4. You can write, my dear students? Yes. So it is 15 meter per second square, and we have taken the acceleration positive in upward direction. We are getting the value positive as well. It means yes, the system will move in upward direction. By putting the value of a in this two equation, 1, 2 and 3 equation, you can find the tension which is acting here, because this acceleration was only unknown. So you can find the tension as well, my dear students. Okay, now here I am giving you one homework on the basis of this question. I will solve this type of question, more questions, my dear students, in next lecture. So don't worry, if you are not getting properly, I will slow down myself and I'll give you few more questions next day. Okay, so never mind. Here the next homework, I think third homework it is. The same question I'm giving. M, 3m, 2m. Okay, and here we are applying a force of 50 Newton. What will be the acceleration of the system? And second, tension in each string. Okay, what will be the acceleration of the system and tension in each string? Okay, my dear students. So kindly note down, pause your video and write down the question. So this is all about today's lecture, my dear students. Thank you very much.